Thomas.
I'm Hannah.
I'm Emily.
And this video is to help prove Ohm's law. Okay, so Ohm's law states the relationship between voltage, current, and resistivity. So V equals IR. So the definition of resistivity is a measure of how difficult it is to push a charge through a conductor. Voltage is the difference in electric potential. For example, on a 9-volt battery, there's a 9 volts difference in electric potential between the two terminals on the top of the battery. Current is the flow of electrons through a medium per time. So, as you can see, it's zoomed in on the resistor now, and if you zoom out, you can see the our depiction of it on the whiteboard. It has the colors on the resistor, and each color actually corresponds to a number, which is a way of showing the amount of resistivity in the resistor. So brown stands for 1, black stands for 0, and the other brown stands for 10. And then gold stands for the percentage error, which is actually 5% for this resistor. And so if you do the math, it'll turn out to be that this resistor has a resistance of 100 ohms with a 5%. So that's the company saying that it will be between 95 ohms and 105 ohms. So as we talked about previously, this resistor is 100 ohms, because you can see from the color bands, and we are measuring that using a multimeter, and you can see that it's within 1% down to 99.2, and we read it as 100, so that's a very good reading. Okay, so here I'm measuring the voltage across the two terminals of the battery. So although it's a 9-volt battery, it has been drained already, so there's only a difference in potential across the two terminals of 7.16 volts. Okay, so this is our circuit with the 9-volt battery set up with the 100 ohm resistor. And as you can see, we're measuring the voltage drop across the resistor. And as you may notice, it's reading 6.17 or 16 volts drop across the resistor. And that's due to the resistance of the wires for that last 1 volt is actually lost in the resistance of the wires between the resistor and the battery. Okay, so what we have set up here is a test showing the current going through our circuit. So as you notice, this ammeter here is set up in series with the circuit, so it's actually part of the circuit. And as you can see, hopefully you can see that it should be reading roughly 0.06, amps, which is exactly what we'd like. It follows Ohm's law perfectly. So as you can see from our calculations here, we have our experimental values on the left and our calculated value on the right. And so experimental is what we actually found when we got the experiment, and that's 0.06 amps was the current. And our calculated value using V equals IR, which is Ohm's law, was 0.062 amps. So you can see that they're almost identical.